Picking up where I left off from the previous video, we could do the same thing for part B, where we are calculating the slope for each line or counting the rise over run, and then we determine which lines are parallel, but I will actually go ahead and skip that. If we're given 2 points that represent a line, we actually are given 2 lines, then we can find out if they are parallel by finding the slope. So remember that the slope formula is y2 minus y1 over x2 minus x1. And we can label our points. So that could be x1, y1. That's x2, y2. And let's find the slope for that first line. So that's going to be -1 minus 3 over -6 minus -5. Again, it's really important that we are careful with our signs because the slopes need to be exactly the same if they are parallel. And if we're off by a sign, then we might get an incorrect answer. So numerator is -4, denominator is -1, and make sure that you simplify it completely so that we see that it's +4. Now finding the slope for B. And labeling the points. -7 minus -2 over 2 minus 3. So that's going to be -5 over -1, which is +5. So no, these lines are not parallel because they are not the same slope. So again, how can you determine if lines are parallel? Same slope. Different y-intercept. Okay. So what if two lines had the same slope and the same y-intercept? So not different y-intercepts, but the same y-intercepts. Would they still be parallel? Well, we could draw. Let's say that here's where my y-intercept is, and I just have a slope of 1 over 1. Kind of a rough drawing. Then, so that's my first line. Then my second line, it will have the same y-intercept and the same slope. So what you have are lines that are on top of each other, or they're the same line. So no, they would not be parallel because by definition, parallel lines never intersect. If they have the same slope and the same y-intercept, then they are just